Hello everyone, I hope you're doing well. So in this video, we're going to discuss Leetcode problem of the day, and today's problem is range sum of BST and it is an easy level problem. So the problem basically says that we have been given a binary search tree and we have been given two integers low and high. We have to return the sum of the values of all the nodes which have the value within this particular range, inclusive both low and high, right? So now this particular problem is essentially not very difficult. So if I have a binary search tree like this, you just have to know the property of the binary search tree, and if you know it, then you will be able to solve this particular problem, right? Now let's say if I am at this particular node and this particular node has a value which is within the range, so there can be only three cases. So let's say this is low and high, right? Now let's say this is the number line. If some value is within this particular range, then it is well and good. I'm going to add this particular value to my answer. Answer plus is equals to x. Let's say we have some value smaller x1 and we have some value greater than the high x2, right? Now if I have this particular value x, I might need to explore some value smaller than it which can be within the range, and some value greater than it which can also be within the range, right? So if I have some value x which is in the range, both the values smaller than it as well as greater than it can be inside the range, right? So in this particular case, I have to make a DFS call or a traversal call to both the left as well as the right halves, right? Now let's say if I talk about x1, I know for sure that this is not going to get included in my answer. But there is one more thing that I should also know, that there is no real benefit if I try to explore values smaller than it, right? There is no real benefit of it. I will only get benefited, or I may only find another unique value if I try to explore to the right of it. That is again not for sure. If I go to the right, whether I'll completely lie inside the range or I will still be outside, but there is a chance that I will get some new values that might lie inside the range. Similarly, for value x2, I know for sure that I do not want to include this particular value in my answer, but again there is a probability that if I explore some smaller values, it might get included in this low to high range. For bigger values, it is never possible, it is never going to get included, but for smaller values there is a chance. So that is why I want to explore this part as well. So for any values, the values greater than the current node will be in the right subtree. So for any value which is less than low, I want to explore only the right subtree. For any value which is greater than the high, I only want to explore the left subtree, because the value smaller than the current value will be in the left subtree, right? So this is how you can solve this particular problem, a simple traversal problem with the simple like observation, right? Now again, I believe the constraints must be such. So there are only 10 raised to power 5 nodes. So even if you visit all the nodes, I don't think that it is going to void the complexity. It is still going to work, but I believe this would be a better way to avoid unnecessary node visits, right? So now here what I have done is I've initialized my answer with 0 and I've called this function traverse and passing it the root node. So if not node, that means if the current node is equals to null pointer, I have to directly return from here. Now I verify if the current node's value is within the range. I am going to add the current node's value to my answer and traverse both the halves, right? Now if I check whether my current node's value is less than low, I only traverse the right subtree, and if my current node's value is greater than the high value, I only traverse the left subtree, right? Now you can clearly see all of my nodes value will lie either in one of these three conditions. Again, I am saying this, it is not essential to verify this particular part. You can always traverse the whole tree, but if you want to save on the number of iterations or the number of node visits, you can clearly use this particular method. So this was all about this particular video. I hope that you guys were able to understand the solution, and before signing off, let me just quickly submit this and show you that this particular code works and the solution is correct. So you see it is passing all the test cases and the solution is correct. I hope that you guys were able to understand the solution again. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.